Now let's have a look at how graphs can be used to mislead you into thinking what somebody wants you to think. The graphs can be manipulated to promote an agenda. So if somebody wants you to think that there's been a big increase or a big drop in something, they might manipulate their graphs to make it look as if that's actually the case. So here's an example from when the new A levels started to come in England. They're saying that the number of A stars has dropped from this red bar to the yellow bar, and the number of A stars and A's has dropped, and the number of passes from A star down to grade E has also dropped. And those drops look pretty dramatic, don't they? But why is this graphic misleading? Pause the video and take a moment to think about it, and then press play when you're ready to go through the answer. The key thing is that the vertical axes don't start at 0. Now, sometimes it's okay to do that, but this emphasizes what's really a very small difference. Whoever published this graphic wanted people to think that there was a really dramatic drop in results. But if we drew the same graphs with the y-axis starting from 0, here's what they would look like. So yes, there's a small drop, but it's not exactly world-shattering, is it? Not such a dramatic drop after all. And some graphs completely omit the vertical scale altogether, so you have no idea what these bars actually represent. Here are some more examples. Why are these graphs misleading? Again, pause the video, have a think about it, work out your answers, and press play when you're ready to go through them. For number 1 then, well, firstly, they're saying fewer than 5, but the 4 to 5 is included in the orange sector. So this is all the people who got 4 GCSEs and all the people who got 5 GCSEs. So if you took out the ones who got 5, it would probably take you back to somewhere around here. So the headline doesn't match what the graph is showing. If they changed it to 5 or fewer GCSEs, or fewer than 6 GCSEs, then it would match the graph. However, also look at the totals. If you add those percentages up, they come to a total of 106%, which clearly isn't possible. It could possibly add up to 101% or 99%, depending on the numbers that were involved and how they'd been rounded. For example, if you had a 49.5% and a 50.5% and rounded both of those to the nearest whole number, they'd be rounded up to 50 and 51 respectively, so they would add up to 101. So that might be excusable, but there is no way that even with rounding, they could add up to 106%. And sometimes you get pie charts showing a total of more than 100% because they were used with questions where respondents were allowed to pick multiple options. In that case, a pie chart is not the right thing to use. It would make much more sense to use a bar chart. A pie chart should never add up to more than 100% unless it's just that very small difference due to rounding. For number 2, well, look at the scales. Let's start by looking at the horizontal axis. We're going from December 07 to September 08. That's 9 months. And then from September 08 to March 09, that's 6 months. So this gap is actually only 2/3 of this gap. And then from March 09 to June 10 is 15 months. So this gap is the same as this one and this one put together. But it certainly doesn't look like that, does it? There's no scale at all on the y-axis. And if you try to read off these lines as meaning something, they don't make any sense at all. Because we've got this one somewhere between 7 and 9, so it must be about 8. And this one's somewhere between 9 and 13.5, so it could be anything from 10 to 12. And this one's somewhere between 13.5 and 15, so it's probably about 14. But there's no consistency there. So the increase, although it appears to be uniform on the graph, it really isn't uniform at all. Then we've got two more to have a look at. Again, pause the video, see if you can work out the answers and press play when you're ready to go through them. So for number 3, the scale doesn't start at 0. We're only going from 590 to 720. So actually, there's not a lot to choose between these products anyway. The differences are exaggerated. It doesn't compare fat content, although it shouts about calories and fat. It doesn't actually do anything to compare the fat content with the others. And they must be trying to make their own product look healthy, but it's the orange bar, so it's not even the lowest one, it's somewhere in the middle. The McDonald's and the whatever the green one is are actually lower in calories, which again doesn't necessarily make them healthier, but that's the idea that this chart seems to be trying to promote. And for number 4, well, look at how far round the circle this bar goes. It makes it look as if 634 is only about 2/3 of the possible total. But if the possible total is 700, you're actually quite close. It's actually about 90% of the total. So the intention here is to make you think that your credit score really isn't that great and you need to do something about it. Therefore, you're going to go and visit their website and use their services. So be careful when you see charts in the press. See if you can work out what message they're trying to give you and have they twisted the data to send that message, because it's very common.